Stella, are you playing in the dirt again?
It's not dirt, it's soil.
What's the difference?
Let's find out. Soil is the uppermost layer of Earth's lithosphere that combines mineral rock with living organisms to create a unique medium capable of supporting life. Soils play an important role in maintaining stream water quality, regulating atmospheric temperature, cycling carbon, and supporting the agriculture upon which much of modern society depends. Without soil, our planet would look much more like the rocky, barren peaks of the Sierra Nevada mountains in California. So by now, you're probably wondering, how do you turn this into this? During their formation, all soils go through physical, chemical, and biological weathering. These processes work together to break down the minerals and organic matter that become the soil. The rocks and minerals are weathered into sands, silts, and clays. Sands are the largest and can be seen with the naked eye. Silts and clays are much smaller, sometimes requiring a microscope to be seen. Clayey soils tend to have higher amounts of runoff. Runoff is the overland flow of water. Runoff rates can be a product of soil texture, soil quality, or urban development. In many urban areas, impermeable surfaces such as sidewalks, driveways, and roadways increase stormwater runoff into streams. This is problematic as runoff can carry road salts, agricultural fertilizers, and other harmful contaminants directly into streams, threatening water quality and aquatic habitat. Biological organisms, both living and dead, play an important role in the development of healthy soils. Earthworms break down nutrients for plants and dig intricate tunnel systems in the soil, creating pathways through which essential water and air can enter the soil. Soils typically contain about 25% water and 25% air. About 45% of the soil is accounted for by the weathered minerals we discussed earlier. The remaining 5% of soil is what soil scientists call organic matter. Organic matter is once living material, both plant and animal, that undergoes decomposition in the soil. This includes leaves, twigs, roots, and even microscopic bacteria that thrive in the soil. Organic matter is an important source of nutrients for the plants, animals, and microorganisms that live in the soil. In addition, organic matter can improve soil structure and water infiltration. Soils with high amounts of organic matter are dark brown in color. In most soils, organic matter is concentrated in the top layer of the soil. The depth to which organic matter extends is largely dependent on the type of vegetation present and the health of the microbial community. The topography and climate of a landscape also play a large role in soil development. Soils in wetter climates will typically weather and develop more rapidly, whereas soils in dry, arid regions will form more slowly. Here at Hoffman Hills Park, many soils develop on steep, rocky slopes, leading to shallower soils abundant in rock fragments. The steep hillside and high amount of rock fragments limits the land's suitability for agricultural and urban developments. However, these lands may be well suited for recreational land use, providing natural outdoor areas for skiing, camping, hiking, and mountain biking. The final soil formation factor is time. Soils tend to develop over large periods of geologic time. It can take several hundreds of years to develop just 1 inch of topsoil. However, soils can be eroded much more easily and quickly. In the 1930s, the Central Plains of the United States became dotted with droves of homesteaders in search of new life. The natural prairies upon which the homesteaders settled were quickly converted to farmland. Without the deep-rooting grasses of the prairie to protect the soil from water and wind erosion, soils were easily picked up and transported by winds. A combination of the severe drought conditions and farming practices of the time led to rapid loss of topsoil. The once fertile soil sediment was carried in large clouds across the Great Plains, wreaking havoc on the new settlers' lives. This era has been appropriately named as the Dust Bowl era. Erosion, however, should be understood as a necessary and natural process of the earth. Rivers erode their banks just as powerful waves eat away at exposed cliff faces. Erosion is just one process that contributes to the complex reshaping of our planet. Imagine it like this. 4 people are playing a game of poker. Each player starts with 5 chips, giving the game a total of 20 chips in use. As the game goes on, the amount of chips any one player has may go up or down, but the total amount of chips in the game will always be 20 chips. Now, apply this to the landscape. After a large rain event, rivers gain power and begin eroding their banks, carrying the sediment downstream. Although the bank, an individual entity in the landscape, loses sediment, another area of the landscape, such as the river delta, gains sediment. The amount of sediment in the landscape remains the same, but it has been redistributed among the different areas of the landscape. Each area supports unique habitat for plants and animals that is essential to the overall health of the planet. Thus, instead of altering the landscape to stop erosion, humans should alter their own activities to respect the forces of erosion. For example, many property owners wish to build houses along the banks of rivers or coasts of the ocean, but it is important to stop and think about how this development may impact the surrounding environment. So now that you've learned about the 5 major formation factors of soil, let's see what kinds of soils you can create. These formation factors can create some interesting structures and colors in the soil. The structure of the soil influences the movement of water and gases within the soil. When you pick up a handful of soil from the ground, you may notice that the soil looks somewhat like crumbs, like when you break apart a cookie. These clumps of soil are called aggregates. The crumbly look of the soil aggregates is referred to as granular structure by soil scientists. This type of soil structure is most common in the upper organic-rich layer of the soil. Deeper below the surface, the soil may begin to look blocky. Blocky is a common soil structure found in the layer of soil below the organic-rich top layer. Many of you are probably familiar with the dark brown and gray colors of soil. However, some soils can be orange, red, yellow, and even blue. The color of the soil may reflect the type of environment in which the soil developed, or the type of minerals present in the soil. Orange features, called redoxomorphic features, can be used to identify the proximity of the soil to the local water table. Some soil scientists collect this information in order to determine the soil's capability of supporting a septic tank or a house with a basement. Soils that are wet for most of the year may develop blue, black, orange, and gray colors. Soil scientists use a Munsell Soil Color Book to determine the color of the soil. Munsell Soil Color Books are a must-have for the student soil scientist, and I never go anywhere without it. As a soil scientist, I often find myself in the midst of Earth's finest creations. But from the deserts of the Southwest to the forests of southeastern Missouri, I'm never quite as happy as when I'm up to my eyeballs in a soil pit. Like myself, many students eagerly dive into soil pits in order to further their skills in describing soils. Soil science can take you on many paths, from studying the relationship between land use and soil health, to connecting the public with information on healthy environmental practices. Some soil science professionals work directly with farmers to come up with ways of farming that protect the soil without compromising agricultural productivity. Others may work with National Park Service or Department of Natural Resources to help maintain healthy habitats in our country's natural areas. But nearly all soil scientists are devoted to conserving and protecting one of the Earth's most important natural resources: soil. My name is Stella Pei, and I love soil. And I hope to have instilled in you, at least to some degree, just how important and amazing soil is. Thanks for listening.